Section 4.3, example 3 on page 258, we have the factor theorem describes the relationship between the linear factors of a polynomial and the zeros of a polynomial. Theorem 102, the factor theorem, says the expression x minus a is a factor of the polynomial if and only if the value of a is a zero of the related polynomial function. So in example 3, we have three parts. Part A, what is a cubic polynomial function in standard form with zeros -2, 2, and 3? Now that theorem we just read says that in order for -2, 2, and 3 to be zeros of a cubic polynomial function, we must have x minus -2, x minus 2, and x minus 3 be factors of this polynomial function. So we can start by writing x minus -2 times x minus 2 times x minus 3, and then we can just simplify this first one. Minus a negative becomes x plus 2. Now, standard form was where you have the biggest exponent first, followed in descending order based on the powers. So this is not written in standard form. What we want to do is multiply this out so that there aren't individual factors. So we can do this using boxes. So if I want to multiply these first two together, I get x plus 2 times x minus 2, x times x is x squared, x times 2 is 2x, x times -2 is -2x, and 2 times -2 is -4. Notice I have an x here and an x here. So if I combine 2x and -2x, they go away and become 0. So that leaves us with just x squared and -4. So x plus 2 times x minus 2 becomes x squared minus 4. That is actually one of the shortcuts we learned a while back. So if you recognize the shortcut, you could have used that as well. The next step is just to rewrite our equation with our x squared minus 4 instead of x plus 2 times x minus 2. Now we have two factors again that we can multiply using a box. Using x squared minus 4 on top and x minus 3 on the side, we have x times x squared is x cubed, x times -4 is -4x, x squared times -3 is -3x squared, and -3 times -4 is 12. So now x squared minus 4 times x minus 3 is x cubed minus 3x squared minus 4x plus 12. Notice this has a squared, this is just x, this is x cubed, this is a constant. None of them are like terms, so we don't combine anything, we just write all four pieces. And that actually becomes our standard form. So we have x cubed first, followed by x squared, followed by x, and our constant is always last. So x cubed minus 3x squared minus 4x plus 12 is a cubic polynomial in standard form with zeros -2, 2, and 3. We can do the exact same thing with a quartic polynomial, except this time instead of having 3 factors, we're going to have 4 factors. Alright, so we have x minus -2 times x minus -2 times x minus 2 times x minus 3. We simplify this to become x plus 2 times x plus 2 times x minus 2 times x minus 3. If we look at the last 3 factors, x plus 2, x minus 2, x minus 3, that's actually what we had in part A. X plus 2, x minus 2, x minus 3, and we multiplied that all out and got this expression right here on the right. So I can go ahead and skip the multiplying out of these 3 and just replace it with this part right here. So again, I already did the work for this up in part A, so we can replace all 3 of these factors by x cubed minus 3x squared minus 4x plus 12. You could have multiplied these two and these two. You could have multiplied them in any order you wanted, but we've already multiplied these 3 out, so let's go ahead and just fill that in. Now I can make a box with x plus 2 and these 4 pieces. So if I take our x cubed minus 3x squared minus 4x plus 12 and put that up top, we can put x plus 2 on the side, and multiplying everything out, cubed times x gives us x to the 4th, x times -3x squared is -3x cubed, and so on. So all of these values inside came from multiplying the top and the side. Now notice we get a lot of pairs. We have a 2x cubed, a -3x cubed. If I combine those, that becomes -x cubed. My x to the 4th was by itself. -6x squared minus 4x squared gives me -10x squared. -8x plus 12x gives me +4x. And then my 24, the constant, is all by itself. So we have f of x equals x to the 4th minus x cubed minus 10x squared plus 4x plus 24 is a quartic polynomial function in standard form with the zeros -2, -2, 2, and 3. Now for part C, it says to graph the function x cubed minus 3x squared minus 4x plus 12, which happens to be the answer we got in part A. And g of x equals x to the 4th minus x cubed minus 10x squared plus 4x plus 24. That happens to be the answer we got in part B. Now notice they use g of x and f of x. it is a good idea to name your function something different if you're in the same problem. Since we were in A and B, I didn't actually change it, but if we're going to compare them, it's good to have different names. You don't want to call these both f of x because they're different. So it says, how do the graphs differ? How are they similar? Now, I should be able to answer some of that without even looking at the graph, right? I know this is cubic and this is quartic. This is an odd leading exponent. This is an even leading exponent. So I know this end behavior is going to have opposite sides. One's going to be up, one's going to be down. Over here, I have an even, which means my end behavior will both be up or both be down. And we should be able to know that based on the fact that they're both positive. We should know what the actual end behavior is, but it's easier to look at the graph. All right, so for part C, you would do this on a graphing calculator, so you're not actually graphing them by hand. If you look at the first one, that is our cubic function. It starts going down and then ends up going up. And for our second graph, the quartic function starts up and ends back up. So they both have x-intercepts at -2, 2, and 3, -2, 2, and 3. The cubic function has a down and up end behavior. The quartic function has an up end behavior. The cubic function has 2 turning points. So notice it's going up, turns going down, turns going up. So that's 2 turning points, and it crosses the x-axis at -2. The quartic function touches the x-axis at -2, but it does not cross it. So the quartic function has 3 turning points. Notice it goes down, up, so it turned here, here, and here. And I would like to point out that it says the first one crosses at -2. So here's -2, we're at the bottom and we cross over. Here it bounces up. Now, we didn't point out why this happens in this answer right here, but if you remember, the quartic had 2 -2 zeros, so we're going to get into that soon. I do, of course, have some worked out computer slides that you can look at that review what we did. They do it a little different, so they don't use the boxes like we do. And then they end with our graphs. So now I would like you to write a polynomial function in standard form with the given zeros, x equals 1, -1, and -2. Notice it's not asking you to graph, you're just going to write the standard form of the polynomial function.